Okay, we're back in the coffin corner tonight, and I just want to make a short video on a very important concept that I have talked to a few of my former mates about that sort of goes related to data center design. As you probably saw in my last little short clip, um, I have a model of sort of an enterprise environment. Um, it's built around a Cisco Axis architecture. And when you extend that to a data center, you end up having usually a aggregation router, which we in the core network business, we usually call it a PE, related to an MPLS aggregation device. And then on top of that, you'll have perhaps a regional core for the United States and maybe another one for global networks. So if you follow the Cisco practice right out of their books, you end up with layers of network equipment that provide boundaries between the layers. And that design works nearly perfectly. So if you do it exactly the way Cisco tells you to do it, you end up with a good result almost always. And so when Cisco goes and sells to the enterprise and the Fortune 1000, that's what they do. They bring their stock architecture. It's a blueprint, and they build that exactly how they've drawn it up, not just for one customer, but for all their customers. So if you go to Cisco and you don't have anything, they'll sell you one that works. It just doesn't allow you to build any intellectual property into your business. So if you stick with Cisco, then your opportunities to develop unique intellectual property in IT really go to application services, and sort of global strategies for delivering apps, which is pretty much the only thing that they haven't carved out of their business, at least at this point in time. So Cisco is moving up the food chain to smart services. They have a few already, like video and voice, but they're pretty far from being an application provider. So in my old world at Bank of America, we were an application provider first, and so dealing with Cisco at the Axis architecture sort of made sense, because we weren't really trying to build a unique architecture. But what happens when you go and make some acquisitions on a global scale like we did with Merrill Lynch and Countrywide, you end up adding these layers not just in one place but in lots of places. And you get these very distributed networks that make you look very much like an AT&T or Verizon does on a global basis, or even BT, Tata, etc. So what I want to talk about today is an alternate strategy. And I have this shown at sort of a small scale in that I have a host, and the host has network cards in it. Furthermore, the host, unlike in the 1990s, is actually running IP. So in this case, I have a Mac host. It has 8 cores. It has 2 GigEs on a single card, and I have 6 slots available. So I could add an additional 6 Ethernet cards, 12 additional ports, and would give me 14 ports. So 14 GigE ports is very similar to a large router, so it would be something that Cisco or Juniper would build, except that instead of running route processing through silicon like they do, very high speed, this would be running route processing through a CPU and interfaces, which is pretty much what the old Cisco routers did when they first came out. So Cisco essentially built a platform on top of Unix code, and over time they migrated it to silicon. So what's happening now in our space is that the mainframe providers used to be, you know, mostly IBM and then Cray and SGI on the West Coast. Now it's pretty much IBM and HP has bought all the smaller companies. So IBM and HP now have these mainframe systems that have added network cards to them, and that changes the paradigm in that these devices can be deployed as routers. Now, to get to that point, you have to deal with things like Zebra and Quagga, which are portable on Unix or Linux. And that means that your base host operating system at the present time has to run Linux. So that's where IBM has gone. So SUSE Linux supports Quagga as part of the platform, and the Z13 and higher series platforms have not just that number of cards as I was talking about, but they actually have 40 gig and 100 gig network controllers that go into the platforms. So why this is important is that if you have an enterprise that is driving aggregation bandwidth into the host less than 100 gigs, then you can collapse your networking architecture to really be the host and some access switches, especially if your host has been abstracted to a core network and data center. So what that ends up meaning is that instead of having lots and lots of access ports where you're doing special engineering and routing on those, you can in fact take your Ethernet cards in your host itself and trunk that directly to a global tier 0 network. And when you do that, you end up ripping out the layers of Cisco access architecture that they tell you to build, but at the risk of having catastrophic failures coming in and out of your host. So if I configure an IBM Z platform with 100 gig Ethernet, I need to make sure that platform is scalable. So what I'm doing, I sort of took an intermediate road. There's one possibility where you essentially eliminate Cisco altogether and trunk to a higher tier core like a Juniper network. The other approach is to say, okay, I'm going to keep my global networks as it is, and instead of having a regional data center architecture and a regional US architecture versus UK architecture, I can eliminate those layers and go directly from my global data centers to my host. And when I do that, I can do some fancy things with access, because how we get on the network today has a lot more options than we did just 10 years ago. So if somebody had come to me and said, we need to add an LTE endpoint, I would say, yeah, right. There's no security on those. It forces us into IPsec and some other technologies. And that was pretty much a non-starter at most of my previous companies. So today, with standards being more mature, more access types, cable companies getting involved like Comcast, Spectrum is now a national company after Time Warner's consolidation. So there are a lot of different access architectures to get to the host that are possible today. Certainly not going to cover those in depth, but there are strategies to take, let the carriers such as AT&T and Verizon, CenturyLink, aggregate that traffic for you and hand off larger pipes into your data center. So we can certainly condense our data centers. We can certainly condense our networks, and when we do, we should be able to take out a tremendous amount of cost. Like at Bank of America, we used to have PBXs and key systems in every branch. and we've removed those completely and went to network services that we put inside of our enterprise cloud, and then we bought exterior services as they came out. So what this ends up doing is I can end up having an access switch like this, that instead of going into a regional environment, I can go directly into a core topology that I either build myself or that I actually lease from somebody like AT&T or Sprint, who offers global MPLS VPNs. So you can buy ports from them on their networks. They build the trunking, and they can create virtual routing tables for you, which is sort of a sophisticated design for those that haven't been around very long. But it's a far different approach than what's taught in the Cisco basic classes that you would get if you just study their architecture. So at the end of the day, what I'm trying to tell you is that what Cisco teaches is best practice if you don't have your own infrastructure already built, or you don't have the investment into people like myself and my friends who do this for a living. So what we're doing is we're really debating whether or not the regional data center architectures that Cisco teaches, whether they're relevant anymore, and then whether or not mid-tier networks like US or Canada also make sense. So I think global network design has changed dramatically, and certainly in a framework where Google Cloud and Amazon Cloud are extending essentially private routing networks across their data center plants already. How you route in and out of those becomes more and more relevant as we go forward. So that's about my summary for today. What I'm advocating is spending some time on routing functions in and out of hosts and how that works. So what VirtualBox does today in software, moving that to a hardware platform would make a lot of sense, and that's what Oracle has stated their plans are for the future. So I think we're in alignment. So Larry usually gets me and I get him, so we're sort of moving in the same direction. But what I think the net result is that layers and layers of Cisco switches at the mid-tier are probably going to go away in my world, but I will end up buying more Cisco large ports and routers like I've done in the past in exchange. But so my little mock-up here is pretty realistic. We're just missing one thing, and that's Quagga, which works pretty well, by the way. And for those network engineers that have been playing with it, it looks very much like a traditional Cisco or Adtran router. So certainly recommend you check it out. Thank you very much, and have a good day.